Welcome. As I told in the last class, today's class I am going to derive expression for locating centroid G for a lamina in the form of a semicircle and also for a lamina in the form of a quadrant of a circle. I told very important, two approaches are there. I am going for approach 1 today. But whether approach 1 or approach 2, see, basic is same. See here, location of centroid G for a semicircular lamina, let R be the radius. Okay, sufficient. If this is R, people know this is R, everything is R, and D be the diameter. Because sometime in an examination, they can give of what? Diameter D. Okay, do one thing. If they give diameter D, you write let R be the radius. Because bookwork you are solving in terms of radius. Then let C be the center of circle. See, this is not circle. Center of a circle for which the given lamina is semicircle. You should write here. Center of a circle, see. This is all I told you. C is not the midpoint. C is the center of a circle for which, you should write here, for which the given lamina is a semicircle. Okay. Centroid is here. See, I already told you this distance not required. This is axis of symmetry. So therefore, centroid lies here. We require only y bar. Sometimes see, I already told it all last class. See, by chance, if semicircle is like this, then this will be x bar. This will be x bar. See, this all I told you. One of them you find it. X bar, y bar, both are same. So, let y bar be distance of centroid G from baseline AB. Okay, I will do one thing. I won't call baseline. See, reference line AB I will call. End to end. Don't from here to here. This line is AB. Okay. C comes in center. As shown in the figure. Class. In the class last time, see, first of all, unless you go through the previous class and start this class, it will not be very clear for you. I already told you. Last time I told all the principles. So first go there, study thoroughly and come. Anybody, suppose somebody wants this expression, he will not see last time. He will open the last class and see only statements are given there. So no, I don't want it. I want this one. He will have confusion. Let him get confused. If he cannot follow what I tell, I am not bothered. I told, this is my strict message for everybody. Want to learn from me, go through everything. Okay. Now, approach 1, I very clearly last time told you. What is approach 1? Or you can write, this is easy approach, but integration little tricky. Not tricky actually. Little difficult, not a problem. Okay. What we will do? Consider elemental strip of thickness D, not D. See, if you want to y bar, if you take variation is y, this is all I told earlier, of thickness dy at y from AB axis. See, from where you want to y bar, from there you take distance at distance, variable distance y, elemental strip of thickness dy, as shown. Let B dash be width of this elemental strip. There is no space to write here. Right here. Width of this strip means already told here elemental strip. And DA be the area of this elemental strip. Now, a neat sketch I will write here. See. As neat as possible. See correctly now. This is your baseline AB. Okay, I will do one thing now. I will extend here. See, I am not telling this CCA. Some reference axis AB. I don't want etc. See, now this is center of the circle. Our lamina is here. Now see, some place you write here. This is R. That also not required. Already shown there. This is radius R. This side is not required. Now you take an elemental strip here. See, elemental strip. See, correct, clear. Of thickness dy, okay, I write here, elemental strip, see, I write here now, of thickness dy, somewhere here, at y from here, see, this is y. Sometimes people ask, sir, is that y up to here or here? No, no. This is so small you can't make out y. Now, see here. I'll project here. This is your width of the strip. See, correct? Clear. This is your width of the strip B dash. I written there. See, statement I written. Let B dash be width of the strip, and for the strip area equal to dA. dA. Now, as shown. Then I told very clearly, then, see, I'll write here now. Then y bar from AB, this all I explained earlier so many times, from AB equal to green color integration of dA into y divided by total area. 1 minute, little space required for limit. Integration dA into y divided by A, area. Now, limit of integration, see, correct, clear. This is R. If this is R, remember, if I project here, actually not required, see, if I project the point here, this also is R, remember, this also is radius R. So, our strip is here. It starts from, see, distance y from here. So, I want to cover the entire semicircle. So, starting from here to there, variation of y is at this from at AB, y equal to 0, and at the extreme end, y equal to R. So, limit is, see, this strip, y variation, see, limit is for y, 0 to R. This is expression for y bar from AB. Wait for, ask it, please wait for some time. Okay, now, I told you something. Get everything in terms of y. See, start now. See now correctly. First of all, we require B dash. You make a note here. We need, what is B dash? You write here. See, somewhere here. We need B dash in terms of y. And dA also we want in terms of y. Okay, we will do it. How? See, light dotted line here. Very light dotted line. Join to this point. Very light line. Join here. Then this will be also R. And this will be y. You can see there, if that is y, this also your y only. See, this also y. Therefore, see, this distance equal to square root of, which one? Your B dash. We have B dash equal to, see, what is this distance? This is, consider right angle triangle. This is hypotenuse. R square minus y square. This is so simple mathematics. Y square. Root. So, this distance will be equal to hypotenuse square minus this square. Root of R square minus y square. That will give you this distance. Remember, it is not B dash. It will give you from here to here. You write there that R's root R square minus y square will give the distance of only half the strip. See, full strip is here. So, multiply by 2. If this is not clear, I cannot do anything. See, such a simple mathematics. See, once again, this distance you see, or right here, you write there, to get B dash using trigonometry, first you get expression for half of B dash, one side, that is R square minus y square root. Same this side is there into 2, B dash over. Then, therefore, your dA will become, now see, now also dA, not therefore, dA equal to area of elemental strip. This can be taken as a strip, means what? Very, very thin rectangle. B dash into dy. This also I told earlier. B dash into dy. Now, substitute for B dash. We get dA equal to 2 times root of R is black, R square minus y square. Then use a bracket if you want. This much times dy. See, B dash 2 root R square minus y square into dy. This is expression for dA. Okay, now do one thing. Correctly see how to go for integration. I will crystal clear explain now. Correctly observe. I don't, no space problem here. Okay, 1 minute. I'll check the camera once, first of all. Have I gone beyond the limit there? No. Surely I am within the limit only. Yes, no problem. Just a minute. Now we will go for integration. I first decided to do the integration in the available space here. Then I decided no. Already you copied everything. So therefore I removed everything. See, this all I will remove now. It's not required. Approach 1, nothing required. Even the sketch also is not required. Okay, let the sketch be there for some time. Okay. Now conclusion part. Just now we concluded y bar from AB equal to integration of dA into y. That y got slightly disturbed there. Okay, dA into y by area. A means area of semicircle. Now make a note. I told this is a very, very easy approach, but integration, you should be careful. You are do by method of substitution. So I will do one thing now. Therefore, now consider numerator. Do one thing. That is, see, numerator is integration of dA into y. Make a note here. One note. It is actually integration 0 to r when variable is y. But we are changing the variable to some other variable now. Method of substitution. Therefore, what we will do is when some t will come now, substitution, y limit is 0 to r. Limit for t will change, but we won't write it because later once again you will come back to y. It is only adjustment. So you do not write here 0 to r. You write later. See, this is already there. You only consider integration of dA into y equal to, see here, integration, black color will do, of dA 2 root of r square minus y square into dy. Remember, this is your dA. See, this is your dA. See correctly there. But into y. See here. 2 root r square minus y square into dy. That is dA. dA is 2 root r square minus y square into dy. Our formula is integration of dA into y, or equal to, see here, integration of r square minus y square root now 2, you do one thing, 2y, I want that pattern, into 2y into dy is the answer. Now see, now make a note, we have to go for method of substitution for that one, for integration. Substitute, you write here, we are going to method of substitution now, that note. Substitute, see this term, r square minus y square, that term as t. In India, usually we take t. Very popular, you know, in mathematics. Now, what to do is differentiate. Differentiating, see, suppose you have y equal to x square. If you write dy by dx, it is 2x. This is one way. Or you can do one thing. If you don't write dy by dx, differentiate both sides. Y becomes dy, x square becomes 2x into dx. You should know that one. So differentiating, r square becomes 0 minus y square becomes 2y into dy equal to, differentiate here, dt, by t is a variable. Therefore, what will happen now? See, 2y, see, there is in integration, there is 2y dy here. Therefore, I write here, therefore, your 2y, see, therefore, 2y into dy will become, this minus goes that side, equal to minus dt. Very important. The minus is very important. Therefore, 2y dy equal to minus dt. Don't remove, forget that minus sign. Okay. Color problem. 2y, see, 2y dy minus 2y dy is dt. 2y dy equal to minus dt. Okay, now do one thing. I'll remove the sketch also. Not required. Because so that full board I can use. I can use full board. Even that also is not required. See, even this also is not required. Okay, now start. Therefore, see here, freely you can do now. Otherwise, I have to struggle for space there. Therefore, integration of dA into y, this becomes, I use a black color, equal to integration of dA into y is what? Root r square minus y square 2y dy. See here, root r square minus y square. R square minus y square is t. T root t, see here, we are replacing r square minus y square t. Root t, 2y dy is minus dt. Root t into minus dt. Or this will become minus outside integration of, you can put t power half into dt. For integration, see, root t is t power half into dt minus outside, or equal to minus outside of t power 3 by 2 divided, okay, write correctly, t power, okay, half plus 1 divided by half plus 1. Half plus 1. dt gone now. Limit, don't put limit, or equal to minus of t power 3 by 2 divided by 3 by 2, or you can tell minus 2 by 3 of t power 3 by 2 is the answer. Integration dA into y. Now replace t by, see, replace t by r square minus y square, because the purpose is over. I said, therefore, your integration of dA into y. Now do one thing. Now go to the limit of 0 to r. See, 0 to r of dA into y will become, see here, minus 2 by 3 t equal to r square minus y square to the power 3 by 2. Limit 0 to r. 0, r can be black, okay. 0 to r. 0 to r, or equal to minus 2 by 3 times, put upper limit r, y equal to r. I use a bracket here, see, I put a big bracket. 2 by 3 outside, first flower bracket, okay. 2 by 3 already gone outside. R square minus y equal to r. R square, one term, to the power 3 by 2 minus, again flower bracket. Put lower limit, y equal to 0. R square minus 0 to the power 3 by 2, or equal to minus 2 by 3, r square minus r square is 0, 0 minus r square to the power 3 by 2. See, r square to the power 3 by 2 is what? You should know that much. R square, 2 will cancel, 0 minus r cube. That much mathematics. See, r square is 0. R square power 3 by 2 is r cube, or minus will cancel, plus 2 by 3 r cube is the numerator. Denominator, that is area. Area for a semicircle, you know the answer, don't waste time. Semicircle is pi into r square divided by 2. In terms of radius, pi r square by 2. Therefore, your y bar from AB will become numerator by denominator, pi r square by 2 divided by, where is it? 2 by 3 r cube divided by, I got a shock of my life, pi r square by 2. Therefore, y bar from AB equal to y bar from AB, I will explain everything after result is equal to 2 into 2 is 4. 4 r cube by r square is r divided by 3 pi. This is the expression right here. This is, you write here, expression for y bar, distance of centroid in terms of radius r. Now, make a note here. Suppose the question is, if you want in terms of diameter, see, now, suppose y bar required in terms of diameter d, then replace r by d by 2. Then your y bar will become how much? 4 into r. R is diameter by 2 divided by 3 pi, 2, 4, or therefore your y bar, you write no space here, you write here. Therefore y bar from AB in terms of diameter will be 4 by 2 is 2, 2d by 3 pi. This is the answer for semicircle. So remember, in terms of radius 4r by 3 pi, in terms of diameter 2d by 3 pi is the result we got for semicircle. I am not showing any sketch now because we are in y as rubbed here. Okay, we have gone for approach 1. At the end of approach 1, our answer is in terms of radius 4r by 3 pi, or in terms of diameter 2d by 3 pi. Now, next class I will go to approach 2, not today. There's a reason. Because approach 2 is some arc you have to take. Why? Because I just now finished centroid for semicircle by approach 1. Now I will do centroid for quadrant of a circle also by approach 1. Okay, then over. Next class I will go for centroid of a semicircle once again by approach 2, and centroid of a quadrant of a circle by approach 2. Then lastly, what we will do? We will write the final result. Or if you are that much eager, you can do one thing. Okay, no problem. Put a result. Therefore, you can write here. See. Okay, last result. Be happy. Result. See. Therefore, for a semicircle, see, semicircle, this is a center, this is radius r, this is diameter d. You can see the diameter d. Centroid will be here. Okay, really. Centroid is here. G. This is axis of symmetry. So this is r, means this also r. Either you write r or you write d by 2 and d by 2 if you want. And this distance, see, from here, your y bar or this distance is 4r by 3 pi, 4r by 3 pi, or you can tell, or it is 2d by 3 pi, Both are same. Okay. Conclusion of approach 1 for semicircle. Now I will go for approach 1 only for quadrant because it is same integration once again. Not much change. But I don't think since it is 90% common, I will write statement first, then I will start. Please save the time. Statement all I will write first. Otherwise unnecessary time consumption. Now, I won't waste time, little fast I will do. Location of centroid G for a lamina in the form of quadrant of a circle. Let R be the radius, see here. Let R be the radius. Diameter you cannot see. D be the diameter, you cannot see it. I have already explained so many times. Let C be the center for which the lamina is a quadrant. Okay. Then now, I already told you, see, 1000 semicircle, there is one symmetry axis, CG lies here. This way is y bar, this way is not required, midpoint. But I told you, quadrant, you require x bar, y bar both. But of course, if I turn here, your x bar will change over to y bar. So, of course, your y bar, x bar both are same. So, right here. This all previous class I explained each and everything. Let y bar be distance of G from reference line AB, see green color, and x bar be distance of CG from EF. We don't waste time. Let us find y bar, one of them. We will find y bar. Okay, now do only y bar. Note, later your x bar will be equal to y bar. Okay. Note, approach 1. Consider elemental strip of thickness dy at y from reference axis AB. See, if you want y bar from AB, you should take y from AB and the thickness should be dy. Let B dash be width of the strip and let dA, I write here, this width of the strip is D dash, so understand, this area equal to dA. Area equal to dA. Okay, now, note, get B dash and dA in terms of y. See, now, see here. B dash equal to R square minus y square. That's all. No into 2. See, I should not tell. If it is semicircle, see here. This is what? R square minus y square root. Then into 2. Here into 2 is not there. In semicircle, see, this width B dash is root of R square minus y square. If it is semicircle, the strip will come up to here. Same strip continues this side. So, there you wrote into 2. The 2 is missing here. It is not there. And dA equal to B dash into dy. B dash is root R square minus y square is B dash R square into thickness is dy. This is the dA. Okay, now I will rub all this one. I want more space. 1 minute. Okay. Now, this all I will remove now. Okay, first I will write here. Then, see, then we have, actually we have is not then, we have, okay. What? Your y bar equal to y bar from where? From reference line AB. Reference line AB equal to integration of dA into y divided by area. A is area of quadrant of a circle. Quadrant, area of lamina, okay, area of lamina, y quadrant, lamina, that is quadrant of a circle. Okay, now, same as last time, start. dA into y, see first, limit required, see here. See again, same thing, y starts from here, you can do one thing, see, if I go for project here, this will be radius once again, r. Therefore, now also, limit is 0 to r. 0 to r. Okay, now, correctly see now, consider numerator, actually repetition now. consider the numerator and make a note, numerator. That is integration of dA into y. That's all. Don't use the limit now. I told you, because when you integrate, you are going for method of substitution. At that time, your what? Limit will change. So don't use the limit. Equal to integration of dA. Where is dA? This I can remove now. Square root of r square minus y square into dy. This is dA. This is your dA. Okay, y square into dy. See, this is your dA. Then without forgetting into y, or equal to integration of root of, this is not divided by a, I told this is your dA, okay, equal to root of r square minus y square into, last time you got 2y dy, this time only y dy into y dy, okay. Let it be there. Okay, now go for mathematics. What I have done just now, same thing, repetition. One 2 is missing there. Okay, that is not a problem. Now I should not explain also. See, this I can remove. Correct, dA root r square minus y square into dy into y. Okay. Everything I can remove now. Nothing required. You correctly, when you write, you should write systematically, very neat sketches. Now, write a note here. We will go for method of substitution. Method of substitution. Do not use the limit. Therefore, now see, substitute root of r square. No, not root. Sorry. Root should substitute r square minus y square equal to t. Now, differentiating minus r square is 0. 0 minus 2y dy equal to dt. See, here you got y dy. Therefore, in the integration where you got y dy, that will become minus dt. Last time it was 2 by 2. Okay. Now, therefore, integration of numerator. Therefore, your numerator, integration of dA into y will now become integration of root of r square minus y square is t. Root t into dy into y is minus dt by 2, or equal to, what you can do is minus half times integration of t power half into dt, or equal to minus half times t power half is half plus 1 divided by half plus 1, or equal to minus of half of t power 3 by 2 divided by 3 by 2, or finally equal to minus of, see, this is 2 is 1 by 2 is there, this 2 will go to numerator, so it will be minus 1 by 3. See here, this 2 will go to numerator. That much mathematics. This will come to denominator, 2 will cancel. If this is not clear, you cannot study anything. So minus 1 by 3 of t power 3 by 2 is the answer. Okay, now consider numerator once again. Numerator, that is, now consider numerator with the limit. And replace t by root of t by r square minus y square. Replace it. What you get? Therefore, your numerator is integration of dA into y limit 0 to r will become integration 0 to r. No integration. No. Integration already over is equal to minus 1 by 3 t equal to r square minus y square to the power 3 by 2 limit 0 to y. 0 not y, 0 to r are equal to minus 1 by 3 big bracket r upper limit r square minus r square to the power 3 by 2 minus bracket r square minus y equal to 0 to the power 3 by 2 are equal to minus 1 by 3 into this is 0 minus r square power 3 by 2 is r cube. 2 cancels or equal to minus will cancel. It will become plus r cube divided by 3. Denominator is A, that is area of quadrant of a circle equal to pi r square divided by 4. Semicircle is pi r square by 2, quadrant is pi r square by 4. Therefore, substitute your y bar from that reference line AB equal to numerator r cube by 3, see, r cube by 3 divided by pi r square divided by 4. Therefore, your y bar from AB, everything I am writing every time, from AB equal to 4r by 3 pi. Answer is same as semicircle. Area is different, later moment of inertia is different, but centroid distance is same, 4r by 3 pi. Okay, now make a note. You got 4r by 3 pi. Make a small note. Suppose y bar is required in terms of diameter. Then replace r by d by 2. Therefore, then your y bar from where? From AB will become 4 into d by 2 divided by 3 pi, or your y bar from same color, from AB equal to, once again, 2d by 3 pi. Okay, we got y bar. And now write, also note x bar equal to y bar. You don't have to calculate, turn it. When you turn, same semicircle will come. The horizontal will become vertical becomes horizontal with no changes. Therefore, write the final result here. Final summary next time I will give you. Therefore, for a quadrant of a circle, this way, you write here, quadrant of a circle of radius r. If you want, write here also, radius r, center here, centroid is here, this is G, this is your y bar. Okay, this side took AB earlier. See, this side took AB earlier. Color is not required now. This side took EF earlier. Y bar from AB is 4r by 3 pi, capital R. Okay. 4r by 3 pi or 2d by 3 pi. Same way, This is your x bar. See, this is your y bar required. Okay, right, y bar. Really, to make more clear, so that crystal clear it is. This is y bar from AB. So this is y bar equal to, in terms of radius, 4r by 3 pi, or in terms of diameter, 2d by 3 pi. Same way, this is your x bar. This also equal to 4r by 3 pi in terms of radius, or 2d by 3 pi in terms of diameter. That's all. Approach 1 is over. Next class I will go for approach 2. There also same result will come. Then I will give final summary of centroid, area and so many principles, where I will start from rectangle, general triangle, isosceles triangle, right angle triangle, circle, semicircle and quadrant. Everywhere I will write area, because why? When you go to next question solve, when the composite sections are given consisting of a rectangle, triangle, semicircle, etc., area required. To avoid confusion, I will give full detail of summary of centroid. Okay. Thank you. We will meet next time.